Hey guys, welcome to Pre-Calc lesson 6.3, ellipse equations and applications. Before we get to the ellipse equations, let's review some factor by grouping. In the first example here, I'm going to group the first two terms and the second two terms. And the reason for that is I recognize if I take out a GCF in the first group, I'll end up with an x minus 3. I take out a GCF in the second group, I also end up with an x minus 3. So because these two are the same, that technique will work. So now the GCF is going to be x minus 3. That comes out front. And what I'm left with is going to be what's left when you cancel that x minus 3 from both. So that's going to give me x squared plus 5. You cannot factor x squared plus 5, so we are done at that point. Now the second example, if you notice, yeah, I could take out an x here, but I'm left with x plus 8y, and there is no GCF of those two terms. So the method we use in example A does not work. Here, I need to factor this trinomial. In order to get you x plus 4y times x plus 4y, which I'm going to write as x plus 4y squared minus 49. Now this you can factor as the difference of two perfect squares. It's kind of like a squared minus b squared. A is going to be x plus 4y, and b is just going to be 7. So this is going to get me x plus 4y plus 7 times x plus 4y minus 7. If you wanted to, you could put parentheses around that binomial, but you don't need to. Okay, next. Get the following into standard form and describe its graph. Well, I can describe the graph right now. Here's what you know. ax squared plus by squared, a equals b. So when a equals b, that means it's a circle. And I just need to get that into center radius form. So I have x squared plus 6x plus y squared minus 10y. I'm going to add 47 to both sides. So now I complete the square on the x's. Half of 6 is 3. 3 squared is 9. Add that to both sides. Complete the square on the y's. Half of 10 is 5. Square that. Add 25 to both sides. So now this works out well. I've got x plus 3 squared plus y minus 5 squared equals, let's see, 47 plus 9 plus 25. It's at 81. So there's the equation, center radius form. And from there, I would just describe my center is negative 3, 5, and the radius is 9. So that's a pretty good job describing its graph. It's a circle. There's the standard or center radius form equation. There's the center and the radius. Okay, well, let's write some equations of ellipses given certain conditions. First one here, the vertices are 2, negative 1, and 2, 9, and it's tangent to the y-axis. First thing I want to do is make a quick sketch. So one vertex is 2, negative 1. The other one is 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's tangent to the y-axis. So that means here it's going to hit at one point. I've got to find that one point. First thing I like to do, let's find the center. Okay, this would be the major axis. What I note here, because I don't want to use my midpoint formula, is that this is 10 units long. So to find my center, I just need to go up 5. 1, 2, 3, 4, 5. That's going to be the center right there. So my center has coordinates 2, 4. Okay? So now, if I'm tangent to the y-axis, that means it's got to be that point right there. Because this would be what we call the minor axis of the ellipse. The ellipse is going to look something like this. Okay, so if you want, you can kind of sketch that in. There's the point of tangency. And you know this is going to be 2 units this way. All right, so now let's write the equation. X minus 2 squared. I'm getting this information from the center. Once you get the center, you can get the top of each fraction, plus y minus 4 squared over something equals 1. This will be my equation. What I need to do is I need to get this number, which will be the x pull squared, and then that number, which will be the y pull squared. Well, we've actually got them both already. This distance here we said is 5. That's the y pull. This distance here is 2. That's the x pull. So here, that's simply going to be 2 squared, or 4. And this is going to be 5 squared, or 25. And there's your equation. Okay, let's move on to the next one. A little bit more challenging here because I give you the foci. Foci of 3, 2 and 7, 2. Length of the major axis is 10, put into standard form. Okay, so again, first thing I'm going to do is make a quick sketch. All right, so I've got 3, 2 and 7, 2. 1, 2, 3, 1, 2. That is a focus. 7, 2, 4, 5, 6, 7, 2. That is another focus. Length of the major axis is 10. Now remember, the foci are on the major axis. So my major axis is going to run this way, horizontal. Well, once again, the first thing I'm going to do is I'm going to find that midpoint. I'm going to use those two to get the center. It's pretty obvious when they have the same x or y coordinates. So I'm going from 3 to 7. I just need the number that's in between those two. You can count here and say, well, that distance is 4, so I just need to go 2 one way, and there's my center. I don't care how you find it. You just need to find that coordinate right there for your center. And that's going to be 1, 2, 3, 4, 5, 2. So again, I can start writing the equation. It's going to be x minus 5 squared over something plus y minus 2 squared over something equals 1. That will be my equation. What you now need to find is the x pull squared and the y pull squared. One of those is usually very easy. In this case, it's going to be the x pull because the major axis equals 10. So if the major axis is 10, that means this entire length here has got to be 10. Or in other words, I go 5 that way and I go 5 that way. Okay, so let's get that. Let's see, 1, 2, 3, 4, 5. All right, should use red. So that's going to be one vertex. 1, 2, 3, 4, 5. That's going to be the other vertex. Now again, you don't really need to sketch the graph, but you need to understand that your x pull is going to be 5. So my x pull squared is simply 5 squared, or 25. Now, how do we get the y pulls? It doesn't say anything about the minor axis, but I do know c. C is the distance from the center to the focus. C equals 2. A in this case is the x pull, so I know c equals 2, I know a equals 5, and remember that critical formula. C squared equals a squared minus b squared. So I'm going to set this up. C squared, 2 squared equals 5 squared minus b squared. So that's 4, it's 25. You subtract that, you get negative 21 equals negative b squared. And then obviously b squared equals 21. I don't really care what b is because b is going to be the y pull. The y pull squared is simply going to be 21. I mean, you could just say it's the square root of 21, then you're going to have to square it anyway to put it in the equation. So I just leave it at that. And this is our equation. Okay, let's talk about eccentricity. What is eccentricity? Eccentricity is defined as the measure of uneven pull of an ellipse. All right, eccentricity symbol is a lowercase e, and it's got a simple formula. E equals c over a. So it equals the focal pull over the major pull. It's not necessarily x, it's not necessarily y. Now, for an ellipse, eccentricity is always between 0 and 1. And we didn't mention this in a circle, but for a circle, eccentricity equals 0. So the closer your eccentricity is to 0, the more round or circular the ellipse is. The closer it is to 1, the more oblong or oval it is. All right, in our next term, the latus rectum, or latera recta for plural, is a segment perpendicular to the major axis that contains the foci. All right, now before I get to the equation for the length, let's just take a look at a picture of what this represents. So in this ellipse here, we've got two foci, F1, F2. The LR is the segment perpendicular to the major axis that goes through the foci. So kind of like stripes on a football. Now it creates these points that are on the ellipse that help us shape the ellipse. L1, L2, L3, L4. You can kind of denote those however you want. That's generally how I will do it. So we've got the length of the LR is 2b squared over a. So this length here is 2b squared over a. Now what we generally do is we like to find the distance from the focus to the L1 or L2 or L3, and we call that the LR pull. And the LR pull is simply half of the length, or b squared over a, and that's what we're going to be using more often than the 2b squared over a. That's great for calculating the total length, but usually we want to find those coordinates because it helps us shape the ellipse. All right, because if these points are closer, then it's more oblong. If they're further away, then it's more circular. So it gives us an idea of the shape of the ellipse. All right, before I move on, I should put the LR pull in the diagram. So this distance from the focus to L1 would be the LR pull. Okay, let's try a couple examples here. Find the eccentricity and coordinates of the endpoints of the lateral rectum and their length. All right, well, this is already in standard form, so I know a couple things right away. Center is going to be 2, -1. X pull equals 4, and that's also going to be A. It's the larger one. Y pull equals 2. That's going to be your B value. All right, so my center is 2, -1. There we go. X pull is 4. 1, 2, 3, 4. That'd be one vertex. I'll call that 2. 1, 2, 3, 4. Here's V1. Y pull is 2. Okay, so this is my major axis, and that would be my minor axis. Now what I need to do next, I need to get the coordinates of the foci. So if you remember foci, it's going to be c squared equals a squared minus b squared. So I've got c squared equals 16 minus 4, which is 12. So c equals square root 12, which is 2 radical 3, which is approximately, I'm going to call it 3.5 for graphing purposes. So 1, 2, 3, right there would be F1. 1, 2, 3, and about right there would be F2. So now, how do we get the LR pull? The LR pull, remember, is b squared over a. So first thing I'm going to do is take b squared. That's going to be 2 squared over a. That's 4. That's 4 over 4. That's 1. So that means the distance from the focus to the end point of the lateral rectum is 1. So from my focus, I go perpendicular, 1 that direction, 1 that direction, and same thing here, 1 direction, or 1 that direction, and 1 that direction. Okay, so about right there would be L1, and about right there would be L2. And over on the other side, about right there would be L3, and right about there would be L4. Now I can sketch in a little bit more accurate ellipse. So now, how do we come up with all those coordinates? All right, coordinates of the endpoints of the lateral rectum. Well, I'm going to use the coordinates of the foci, and I'm going to add 1 to the y and subtract 1 from the y. Well, how do you get this coordinate? You start with the center, and you subtract c. So minus 2 radical 3 from the x coordinate. All right, so it's helpful to get the foci first. F1 is going to be 2 minus 2 radical 3, comma negative 1. And F2 is going to be 2 plus 2 radical 3, comma negative 1. Now, to get the L1, L2, L3, and L4, here's what I do. I take the coordinates of F1, so this one, and I add 1. Now, you can see from the graph, obviously, this is pretty easy to do, but let's say the coordinates are messy. Add 1 to the y coordinate, and then for L2, I'll subtract 1 from the y coordinate. All right, so what I get there would be 2 minus 2 radical 3, comma 0, 2 minus 2 radical 3, comma negative 2. And then what's kind of nice, it's got symmetry, right? It's a rectangle. So for these coordinates, now I'm going to take the 2 plus 2 radical 3, that's going to be the x coordinate on both, and then those y coordinates are going to be the same. So this is going to be 2 plus 2 radical 3, comma 0. This will be 2 plus 2 radical 3, comma negative 2. One more thing it specifically asks us to find is the eccentricity. So let's do that. Eccentricity, I'm running out of room, is c over a. And c is 2 radical 3. And a is 4. Now, if it says simplest radical form, that would just be square root 3 over 2. Let's see, it doesn't say. Or it might say like nearest thousandth. Let's see if I calculated that to nearest thousandth. I did. I got about 100th, 0.87. It's approximately what I got. One of the cool things about an ellipse is its reflective properties. So what happens, I'm going to skip through this, I'll tell you about the description. In an ellipse, anything that's emitted from one focus will reflect off the ellipse and go to the other focus, no matter what direction. So that's kind of neat because we can apply this to different instruments. One of them is called a lithotripter. It's an elliptical reflector, and it's used to break up kidney stones by generating sound waves. So one focus here will generate the sound waves. Let's say this is the body, and here's your kidney stone. So by itself, a wave is not strong enough to damage any tissue. But what happens is all those waves then get focused over here on the kidney stone and then just break that apart. Another application of this, and I don't know if you guys went to the Washington, D.C. field trip when you're in middle school, but it's called the whispering chamber. So this is a room, and it tells you right here the dimensions are 46 feet wide, 96 feet long. And 2 people would stand on the foci of the ellipse or the chamber and whisper. And the cool thing about it is you can whisper in the opposite direction. And this person, anywhere else in the room, any of these people over here would not be able to hear you at all. But what happens is the one person standing exactly on the other focus would hear you because all your sound waves, even though individually might not be loud enough to be heard, get reflected back to the person on the other focus. So that's kind of a cool application of an ellipse and the reflective properties. You also see these in headlights. So what we're going to do first here is we're going to use this application. We're going to come up with a standard equation that represents the outline of the room. And they give you some parameters. Assume it's a horizontal ellipse and let the center of the room be 0, 0. Obviously, you want to make this as easy as possible. So what I notice up here, the length is 96 feet. That represents the length of the major axis. So I'm going to take some notes up here. If the length of the major axis is 96 feet, and here's my center, that means my x pull equals 96 divided by 2. All right, so what's that, 48? So x pull is going to be 48. My y pull is going to be 46 divided by 2, or 23. So this is a pretty easy equation to write. My center we're going to assume is 0, 0, so it's just going to be x squared over something plus y squared over something equals 1. And remember, the number that goes under here is x pull squared. Well, that's going to be, 48 squared. Kind of a big number, 48 squared. I got 2,304. And then for my other one, that's going to be y pull squared. So in this case, that's going to be 23 squared, and 23 squared is 529. All right, so there's our equation. And the second one wants us, if two senators are standing at the foci of this room, can hear each other whisper, how far apart are the senators? Round to the nearest foot. So I'm going to make another sketch down here so I don't have to keep scrolling up. So that would be F1, that would be F2. Basically what I want to know is this length here. Well, there's my center. What I need to find is little c. And remember our equation, c squared equals a squared minus b squared. Take a look at the equation from up above. C squared equals 2304 minus 529. And let me throw that into the calculator. I got 1775. So C equals the square root of 1775, which is approximately 42.13. Now, remember, what is 42.13? It's this distance. The question wants us to find how far apart are the senators. So they want this total distance here, which is basically going to be 2 times C. So 2C equals 2 times 42.13. It says round to the nearest foot. I throw that into the calculator. I got 84 feet. Okay, so I threw a lot at you today. This is going to wrap up ellipses, the equations, the applications. We're going to have a work session where we can review some of this, but please make sure you pay attention. Check your answer keys on the homework. This is a very tough unit. I know I keep saying that, but it's very important that you guys stay current. Thanks a lot for watching. Please reach out if you have any questions.